We are actually getting some rain. Yes, we actually got a little bit of rain this evening. How about that? There's some. That's a nice sight to see in the middle of August. Some towering cumulus there. This is looking off to the. That other shot was looking off to the southeast, but this is kind of what the evening looked like this for today. And here's what we got on the map for today. You can see there's a little bit of a difference in the wind direction right along this axis. See that right there? East of that axis we have east-southeast winds blowing kind of like that, and west of that axis we have southerly flow coming up from the Gulf like that. So this is probably the remains of that old front that came through over the weekend. If you remember the past couple of webcasts, we were looking at that front that was kind of sagging towards Oklahoma, out to Arkansas and Mississippi and Alabama. There we go. And that air mass kind of like sank southwestward through Louisiana, and now we're seeing that kind of like poking into the east part of East Texas here. Okay, there's the satellite, the visible satellite imagery, and we can see a few showers through this area here, and that's pretty much what we're seeing at this time. Got that boundary running through East Texas, and we've also got a bit of a area out to the west near Abilene and Guthrie and Childress. A few showers going on there also. So what's causing that? Well, it's a good question. It's kind of masked, but you can sort of see this outflow boundary painted out like this. So this would be a little bit of a meso-high, centered right over Guthrie, the same place that was getting some rain yesterday, and we're getting some outflow from that. Now, I don't think that's a dry line because the dry line is well out to the west. It's all the way back into New Mexico. This probably originated from this air mass flowing northwestward, hitting the cap rock and getting a little bit of localized lift right in this area. So that's probably what happened with those storms that we have going on in that area right now. Got some stronger stuff. Let me pull up the 250 millibar chart. We've got this polar front jet running from Nevada to Utah up to the Dakotas. And we've got a bit of an MCS moving into the Minneapolis-St. Paul area. So there we got that right there. That's a big MCS and a few cells out ahead of that. If I go up to higher tilts, what do you think that is? You see this ring around the radar like this? Any ideas what that is? That is the anvil from that MCS. Anvil is spreading towards the southeast, maybe to the east-southeast, and it's overlying the radar site. And there it is right there. As we go up to higher tilts, this is up at about 15,000 feet, and there's the radar site. When we hit that 16,000 foot level, we start picking up the anvil. So if you picture the radar beam going to higher and higher levels, that's where it hits the anvil right there. So if we have the radar beam shoot to the southeast, we pick up the anvil at about 25,000 feet. So it's a little bit higher out in that area. GR2 is it's a pretty cool program. You can set up these three-dimensional displays, and I think that's probably picking up the anvil right there. You see that right there? So this is again, this is in the Minneapolis-St. Paul area. Certainly not getting anything like this here in Texas. And when we start getting some of these stronger storms as we get into fall, I'll probably run through these GR level 2 products a little bit more. But as far as this goes, this is not really a particularly severe area of thunderstorms. Let me pull that back there. There we go. This is not particularly severe. If we go up to higher tilts, you can see it's not really, we don't have these cells tilting downwind or anything like that. This is pretty, it's pretty much a garden variety area of storms here. And it goes all the way back towards North Dakota. So anyway, that's probably about all I have to say on that. Now let's see, soundings for this evening. We've got a few showers and storms in the North Texas area, and that's because the cap has weakened a little bit today. So if I go from, say, a parcel lift from 95 degrees Fahrenheit, again, this is 12Z, so we don't have the evening data in yet, but we take the lowest 150 millibar level, and we get a lifted parcel LCL right about right there. And then our lifted parcel goes up like that. So there's a lot of positive area and not very much negative area right there. Because we've had a little bit of cooling in the mid-levels, and that's helped to trigger a few of these showers and storms that are going on right now. All right, what else do we have going on across the country? I'm losing my voice here. This is pretty much all heat advisories for the Texas, Oklahoma, and Kansas area. This is because of the high dew points that we've got across this area. See that right here in East Oklahoma, we got 74 dew points right there at Muskogee. McAllister's got 73, even 76 there around, not sure what station that is, probably Idabel, and even 77 there in DeQueen, so definitely got some good moisture in place there. And what do we have in store for the upcoming week? Well, let's look at the GFS run here. Starting out here on August 10th for today. And we're pretty much sitting under this high pressure area right here over Mississippi and Alabama. A little bit of it extends out towards central Texas, and that's the reason we have these 100-degree temperatures across Texas right now. But we've got a polar front jet working, and my phone keeps going off. It keeps getting these text messages. Let me see what's going on. Make sure it's nothing urgent. Okay. My kid needs help. He's got like a virus on his computer, so I'm going to take care of that after I get off the webcast here. Anyway, there we go. Polar front jet, probably a bit of a subtropical jet, also possible. I don't know. Is that a subtropical jet? For that we really have to go up to the upper levels, up to 200 millibars to figure that out. So let me pull up a product for that. Need to update this bookmark here. College of DuPage they've got a lot of good weather charts. I definitely recommend checking this out. Let's see, upper air charts here. Don't seem to have a 200 millibar chart. I guess 250 millibars is about all we can do here. The other way we can figure this out is we can pull up the soundings. I can pull up a sounding for Arizona, for example. Let me pull up Tucson here. And I don't see much in the way of very strong upper level winds. I got 35 to 40 knots right up here. This is what I'm trying to do is I'm trying to figure out if this is baroclinic. If this jet here is baroclinic. I got another text come in. Okay. He's having some issues with says the Java installer is confusing or something. I can go do it in a while if you can't. Well, that's what I'll be doing here in a few minutes. But anyway, let me go back to this. If we want to figure out if that jet across Arizona and Nevada is baroclinic, probably a good product we can look at is the thickness. Thickness gives us kind of a idea of the temperatures, the average temperature in the troposphere from about 1,000 up to 500 millibars. So basically the lowest 18,000 feet. Okay, so this is our chart for right now. And we can see that Arizona is pretty much covered by this high pressure area loft. So this is going to be an upper level high, probably tied into the thermal low across Arizona. So I think what we're seeing there on the upper level charts is probably more in the realm of a subtropical jet. And then out here we probably pick up a little bit more of the polar front jet energy, running something like that. So we're basically looking at the tightest thickness gradients. See that right there? That's going to pretty much define where the upper level jet is. And we've got a upper level low right there over the eastern part of Hudson Bay. That's going to be a barotropic low that's associated with an occlusion up in that area. So we're going to find the jet running something like that. And if you remember, we've talked about in some of the past webcasts about positioning the low-level front, or I'm sorry, the front at the low levels. That's going to be pretty much centered right in that area right there. So we're looking at the trough right in that spot right there, a ridge right there, and the front is going to fall basically between that trough and this ridge downstream. So you can kind of use that. You can use that technique to kind of figure out where you're going to find the fronts at the surface. So there's our Ontario surface chart. You can see that there's a definite difference between the air mass over central Ontario and Michigan, where they have 88 degree readings, 81 here, 78. So we're going to find the front probably something like this right here. So that's going to be the approximate position of the front, and we've got those storms that we saw earlier. That's going to be along the cold front itself, so that's the reason those have fired up in Minnesota there, so along the leading edge of that front. And I think that's pretty much it. I did see on the I did see on the 250 millibar charts for next week, it looks like we will get a change coming up around Wednesday or Thursday next week. Let me show you that here. See that we're picking up some much stronger upper level flow across North Texas, Oklahoma. So we've got a pretty good shot here around midweek next week of some thunderstorm activity across Texas and Oklahoma, so probably in this area. That'll give us something interesting to look at, I'm sure. as we get into next week. Anyway, that's about all I have for today. I'm going to probably, either tomorrow or the next day, I'm going to show you a bit of astronomy. I dug out the telescope, and I'm going to show you a little bit of probably a few shots of the moon and whatever planets are out there, and we'll check that out. That'll give us something different to look at. Anyway, thanks for watching. I appreciate you tuning in, and I will see you tomorrow night.